The average monthly high temperature in Charlotte, North Carolina is given in this table. We are first asked to find an equation for a model of these data. Well, before we find an equation, we have to first see what the data look like. So let's bring up our calculator and let's edit our statistical data. Now we have month names here, so that's not going to be very useful. Let's get some numerical values to this. So let's let T represent the month of the year. So then March would be T equals 3, April would be T equals 4, etc. through November would be T equals 11. And I'm going to say let M represent the month instead of T. M. All right, and we'll let T of M represent the monthly high temperature. All right, so let's put in our data values here. Stat edit. 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, and our outputs 62, 72, 80, 86, 89, 88, what we got? 82, 72, and 62. I think. Let me just double check that. Yes. Okay. All right. Window. Let's go from 0 to 12 for our months, and for, let's see, our minimums were at 62, so let's go a little bit lower. Let's go to 55. And our maximum was 89. Let's go a little bit higher to 95, and I'll use a scale of 5s there, I guess. All right, so y equals, I've got my plot 1 on for L1 and L2. Let's graph it. Hey, that looks pretty good. That looks quadratic to me. So, let's look at it. And in fact, it looks like the vertex is that point right there, which is the July temperature. So let's take the vertex to be 789. So what I now know is I can write the model T of M would be A. I've got to figure out the value for A, and then we would have M minus 7 plus, I'm sorry, M minus 7 squared plus 89. Since the vertex is 789, I can write M minus 7 squared plus 89. Now I've got to figure out the A value. So what I do is I pick another point on the curve that I think represents the model well. Again, it's sort of like an eyeball best fit. So I'm going to pick this point. I think a curve that would go through that point would go pretty well with the rest of the data. So I'm going to using 472, I will solve for A. So then that would give me 72 is equal to A times 4 minus 7 squared plus 89. There's only one variable left there, A, and so I can solve for that. 72 is equal to A by negative 3 squared plus 89. 72 is equal to, well, negative 3 squared is 9. A times 9 is 9A. 9A plus 89. Subtracting the 89 from both sides, negative 17 is equal to 9A. Dividing through by 9, A is approximately, let's see, 17 divided by 9. It's 1.888 repeating, so let's say negative 1.89. So then our model would be T of m is equal to negative 1.89 by m minus 7 plus 89. Now, it would be a good idea to check this model along with our data. So y equals negative 1.89 open quantity x minus 7 close quantity plus 89. I missed the square, and I didn't write it down here either. Gotta remember to write that. So let's insert the exponent, okay, and graph it. And I'd say that looks pretty good. All right, so now what are we asked to do? Using the model, estimate the average high temperatures during December. All right, so December would mean m equals 12. So then T of 12 would be negative 1.89 by 12 minus 5 squared plus 89. I'll use the calculator for that. All right, so let's quit. Negative 1.89 by 12 minus 5 squared plus 89. And that gives us negative 3.61. All right, so that doesn't seem, hold on, did I? Oh, it's supposed to be 12 minus 7. I don't know where I got that 5 from. 12 minus 7 squared. I was going to say that didn't sound reasonable. All right, so let's change that 5 to a 7. 41.75. All right, so using the model, so according to the model, the average high temperature for Charlotte in December is 41.75 degrees Fahrenheit. The actual average high temperature in December for Charlotte is 53 degrees. Now remember, the model told us that T of 12 was 41.75. How well does the model predict this value? So not very well. We would hope that it would be close to 53, but it ended up being pretty far away. So it's not a very good model. And so probably what this means is this was a model breakdown. And so we maybe want to consider that that this model could only best be used near July and doesn't work as well outside of a few months.